Hello everyone. Today in this video we will try to give an introduction to TCP and a small introduction to network security. The contributors to this video are Rency Joseph, Deepali Upadhyay, Kanika Jain, Shefali Munjal and Jasmeet Singh. The agenda of this video. First we will look at a comparison between TCP and UDP. Then we will look into the details of the TCP header. After that, we will see how TCP handshake works. Then we will see an introduction to network security. And finally, we will look at what firewalls are. So let's dive in. TCP versus UDP. TCP and UDP are two internet protocols. They are widely used for different purposes, of course. First is UDP, that is the user datagram protocol. UDP is a connectionless protocol that offers a direct way to send and receive datagrams over IP network. So that means there is no need to establish a connection beforehand, and that data can be sent over to any other program over the network. So using UDP, a program can send a load of packet to another, and that would be the end of the relationship. UDP does provide checksum so that the data integrity is maintained. However, it does not send any acknowledgements, or it does not have any error control or flow control or congestion control. So, UDP is suitable for applications that need fast, efficient transmission of data, such as games and media streaming. Also, the order of data is not maintained. So if any application using UDP needs to maintain this order, it has to do it by itself. Next is the TCP, that is a transmission control protocol. It is a connection oriented internet protocol to exchange stream of data. So that means that you need to establish a connection before you can send any data over the wire. TCP does guarantee the delivery of the data in the right order without duplication, which is not the case in UDP, as we just saw. TCP also includes flow control and congestion control. So TCP is suited for applications that require high reliability, but the transmission time is less critical, as TCP is a little slower than UDP because of the mm, process that it needs to establish a connection. So it is used in web, SMTP, SSH, FTP, Telnet, etc.
Let's start with TCP segment structure. As you can see, similar to UDP, the TCP header includes the source and destination port numbers, which are used for multiplexing and demultiplexing the data from and to the upper layer applications. The header, it also includes the checksum field. Apart from these, we have other fields as well in the segment. Some of the major fields are the 32-bit sequence number field and the 32-bit acknowledgement number field, which are used by the TCP sender and receiver in implementing a reliable data transfer service. The 16-bit receive window field is used for flow control, and the 4-bit header length field specifies the length of the TCP header in 32-bit words. The TCP header can be a variable length due to the TCP options field. The optional and the variable length options field is used when a sender and receiver negotiate the maximum segment size, or it can be used as a window scaling factor, which is used in high-speed networks. There also a timestamping is available. The major field is the flag field, which has 6 bits. The ACK bit is used to indicate that the value carried in the acknowledgement field is valid. That is, the segment, it contains an acknowledgement for a segment that has been successfully received. The RST, sync, and fin bits are used for connection setup and teardown. Also, setting the PSH bit indicates that the receiver should pass the data to the upper layer immediately. Finally, the urge bit is used to indicate that there is data in this segment that the sending side upper layer entity has marked as urgent. The location of the last byte of this urgent data is indicated by the 16-bit urgent data pointer field. The TCP must inform the receiving side upper layer entity when urgent data exists and pass it a pointer to the end of the urgent data. In practice, the PSH urgent and the urgent data pointer, they are not used. That's about the TCP segment structure.
Hello friends, today I am going to speak upon three-way handshake established in TCP, that is Transmission Control Protocol. We need three-way handshake to establish a connection in TCP. To establish this connection, we need a client and a server in which server is listening. Client tries to connect to the server and sends the first packet called SYN, meaning synchronize. The alphabet that you can see after SYN is nothing but ISN, that is initial sequence number. In this case, the initial sequence number is X. The server receives the packet and answers with the SYN plus ACK. The initial sequence number for SYN is Y and for ACK it's X plus 1. Then the now the connection for the client is established and the client confirms this status by sending the ACK with the initial sequence number as Y plus 1. Finally, as you all can see, the connection has been established between client and a server. That's all from my side. Thank you for listening.
Discuss about cryptography and goals of cryptography. So first of all, what is cryptography? Cryptography is basically the science of writing the data in secret code so that no other person except the intended receiver could read it. So it is basically for secure communication in the presence of third parties. More generally, it is about constructing and analyzing protocols that can overcome the influence of attacker or outside people. So there are many applications of cryptography which includes ATM cards, computer passwords and many more. So mainly cryptography is the science of using mathematics to encrypt and decrypt the data. So it enables you to store sensitive information or transmit it across insecure networks so that it cannot be read by anyone except the intended recipient. So there are various attacks. So for example, spoofing, tampering, snooping, replay, man in the middle attacks. So main goal of cryptography is to protect the data against these type of attacks. So now we will study about the goals of cryptography. There are mainly four goals of cryptography: confidentiality, authentication, integrity, and availability. So, the first goal is confidentiality. It is basically the most commonly addressed goal, and it means that the meaning of the message is concealed by encrypting it or encoding it. The sender will encrypt the message using a cryptographic key, and there are many type of cryptographic key that we will discuss in the next lecture. The recipient will decrypt the message using the cryptographic key that may or may not be the same as the one used by the sender. So the second one is data integrity. So integrity ensures that the message received is the same as the message that was sent. It basically uses hashing to create a unique message digest from the message that is sent along with the message. So the receiver uses the same technique to create the second digest from the message to compare to the original one. These techniques only protect against unintentional alteration of the message.
and a variation is used to create digital signature to protect against malicious alteration. The third one is authentication. A user can prove their identity to another who doesn't have personal knowledge of their identity. This is basically accomplished using third party or using digital certificates. Mainly, Kerberos is the common cryptography authentication system. So, the fourth one is availability, which means that assuring that the data and the services are available all the time. So, we will discuss all the four goals in detail in the next lecture.
Hello everyone. As you have seen the topics about TCP IP and cryptography, now in this I'm going to cover about firewalls. What is a firewall? A firewall is a system or group of systems that enforces an access control policy between networks. And what's their function? We want to block traffic, we want to permit traffic, we want to enable secure remote connection, that is like VPN, logging traffic, content filter, or we want for a management purpose. So what are the main goals? There are too many, but I am going to highlight a few of them. First is like we want to protect our internal network topology and service, and we want to protect against the protocol errors like SMTP. We can even like separate the network to a subnetworks, and when the intruders will not be able to compromise whole system, it will like one subnet is down, not the complete whole system is down. So that's a main purpose of like firewalls come into picture. Now now what let's talk about like what two there are two types of firewalls. One is packet filtering on network layer of the IP stack. It's a rule based. It's like some permit, some default, deny design. uh, Most routers these days comes with the packet filtering capability. Now how we characterized a packet filter, how good it is, it depends upon the what type of services they are permitting, which are actually needed. It's not just trying to hide what is not need to be shown, but also the services that are not in use. Secondly, it hides the internal network like elements and architecture. Filter services labeled to the internal host, like we want that the YouTube like can't be watched within the working hours, so we can forbid that and can be allowed like after 8. So this type of now packet filtering can be of like stateless or stateful. I will elaborate more on this in the further slides. Before that, how to define a packet rules. It can be IP protocol like UDP or TCP. It can be source destination IP, port number, connection state, or even like time schedule or rate control. What is an application gateway? Proxy rebuild the whole protocol. It needs to know the exact specification of the protocol we use, and the benefit is it has high security. But yeah, we have to compromise somewhere. It leads to a low performance, and it becomes more complicated to the internal users in the case of like telnet proxy. So what is the major differences between these two, packet filter and the application gateway? Packet filter in a stateless, it's like unsecure. But when we talk about the stateful, in that it is easy, but it is possible that it not be able to support all the protocols. And in the application gateway, it's more sophisticated, but yeah, we lose the transparency. So if there is an internal web server beyond an application gateway, cannot log who is downloading the pages. These days, like we are using a mix of match of both packet filters as well as the application gateways. Let me give you a small uh, architecture overview of both of this. So basically, this firewall is a place where we can have a like packet filter or an application gateway. So this is the place exactly. And that's it, like I'm telling you that we are using a mix of match of these. So this is, we can have a packet filter only with the like screening routers. So this can be used like one router, because these days routers come with the inbuilt feature to have the screening of packets. And this is what I'm talking about, that is a application level firewall. And this, we have this bastion host, and there is a packet filter, and then there is a router. So this is a mix and match. So with this, I'm going to wrap up this session on firewall. Hope this session is useful and the other sessions as well. So we are going to give more session in future related to basic concepts. So hope you will like this video and stay tuned to have our new uploads in coming days. Thank you.